So Nate grabs his keys on the way out the door, maybe fumbles them a little bit trying to get his car unlocked in the freezing cold, before finally getting that door unlocked. He then jumps in, sits down, and gets ready to get that car warmed up for a drive to work. He takes his keys, he plugs them in, and thinks to himself, my car is very much dead. He's definitely frustrated after living in Troy for a little bit. So he stops, checks the weather in disbelief, thinking it can't possibly be that cold, before he looks and thinks, you have got to be kidding me. So you jump out, pop the hood, do a little inspection about what needs to happen, and grab the jumper cables because this is not the first time that it has happened. When you get to the hood, you realize no one is there to lend you some juice. In Troy, New York, this is a very common occurrence, and you can avoid this kind of situation with a little bit of knowledge about how batteries work. With a little bit of help, you won't be that guy. Hello everyone, my name is Nate. I'm a Senior Engineering Ambassador at RPI, and Chris is also a Senior Engineering Ambassador at RPI. As you saw, dealing with batteries in the cold can be incredibly frustrating. So today we're going to talk about how a battery works, why it is frustrating in the cold, and then how you can prevent that from happening in the cold. So Chris is going to start us off with how a battery works.
Thanks, Nate. So we have a basic drawing of a just very simple battery up here. Before we even get started, I'll show you. Here's just a normal AA battery like you would see in a video game controller or a TV remote. And you can see that's what's drawn up here. So we have the black terminal, which is positive, and then the red one, which is negative. And there's a blue wire connecting the battery to a light bulb at the top and then back to the positive end of the battery. And you can see that there's these purple circles or electrons flowing out from the negative end to the light bulb, giving it energy, and then back to the positive end. And the reason it comes back to the positive end is because opposite charges attract, and therefore the negative comes back to the positive. As I mentioned, there's two terminals here, positive and negative, and that's how the battery functions. And the negative end, because it's losing negative charge, is being oxidized, and therefore it's called an anode, while the positive end is gaining negative charge and it's being reduced, and therefore it's called a cathode. So now we went over a very basic battery and the layout. I'm going to address more why exactly cold weather impacts batteries, especially with winter coming up and all the storms that we get up in Troy or wherever you are for the winter. Your batteries can definitely be affected. So one type of battery that can be affected, like Nate said, is your car battery. That's actually a lead acid battery, and then your phone battery can also be impacted, and that's called a lithium ion battery. Those two terms are not too important. It just refers to what kind of chemicals are on the inside here, but we don't need to get into that. They operate generally the same, just in terms of how they're affected by the cold. And so what exactly cold weather does is it makes the flow of these electrons harder, and so the battery has to work harder in order to get the electrons out and power the light bulb or your phone or the car or whatever the battery is there for. And so the colder the weather it is, the colder the weather is, the harder the battery needs to work, and the faster it'll drain power.
So everything of what Chris said is true when the battery's in use. But for storage, it works a little bit different. You might notice your grandparents or your parents storing their AA's in the fridge or freezer, and that's because when it's in storage, keeping it in the cold actually maintains the charge better because the electrons are not leaving the terminal of the anode as quickly as they would be in a normal room temperature or even a hot environment.
So now that we've talked about how cold weather impacts the battery, whether it's in storage or use, we're going to talk about preventative measures to help keep your battery at the highest charge possible while it's in use in cold weather. And so this is the one area that it can vary a lot battery to battery. For example, while Nate said we might keep AA batteries in the fridge, you usually don't want to put your phone in the fridge because that type of battery doesn't respond in the same way. But overall, there's a few things across all batteries that can help. So first off, just keeping your battery charged frequently and regularly is a good way of making sure that you'll maintain the charge. Also, you don't want to expose it to cold environments while it's in use. So for example, if you're let's say, ice skating in a park, you might not want to take out your phone and, snap a lot of pictures while on the ice because it's so cold. Also, if you're driving your car, you might want to wait for your car to heat up or the engine to heat up before you start driving and really put any strain on the battery or car. And overall, if you just take some of these preventive measures, just try to keep the batteries as normal of a temperature as possible while they're in use, then you can really elongate the lifetime of the battery.
So overall, we went over how a battery works, with the electrons leaving the anode, traveling through the wire, and going through the cathode to produce energy for whatever it's powering. Then we jumped into the usage of batteries in the cold, and how if you're using it in the cold, it might discharge faster, but for storage, it might be better for certain types of batteries, depending on the application. And then finally, we talked about basic preventative measures for every battery, and basically going over how to use some common sense tips to elongate the life of your battery in winter in Troy.